So we found two things. The first thing was that there was certainly a better device. It was actually pretty accurate. The level of accuracy was the maximum error that we found was around 0.01 meter per second, and we also found that this error was unbiased. This means that there was no preference in this device to overestimate or underestimate the actual velocity of the device of the barbell during testing, while most of the other devices that we found actually presented a bias.
Hi, Francesco. It's my pleasure to have you the second time. The first time we've been talking muscle activation, using straps, not using straps, and this time we'll be talking about velocity. But before we get there, could you please briefly introduce yourself?
My name is Francesco Travascio, and I'm associate professor at the Department of Mechanical and Aerospace Engineering of the University of Miami. I'm also a master weightlifter, and I really enjoy doing studies in weightlifting and sports-related biomechanics.
So we're talking velocity, measurement of velocity in weightlifting movements. If you would tell me first why you decided to set up the study.
Well, I was very fascinated about the training methodology based on barbell velocity. I find it that in principle, it seems to me a very rational approach to the optimization of the performance of the athlete. At that time, there were a number of devices that were used for tracking the barbell velocity. Obviously, the first thing that we started to do was to look into those that could be more immediately available for a general user. And we looked into camera apps, phones or tablets, and we found one that at that time seemed to us a very interesting type of app, very, very nice. And we also wanted to compare the accuracy of this system, obviously with our gold standard that is within a gate lab, a motion capture system. It was an OptiTrack system that we used. Another problem that we found, and we actually couldn't find a practical solution for that, was the fact that some of these devices are built as boxes with a rotational encoder and a wire that is attached to the side of the barbell. When the barbell is lifted, a cable is pulled out of this device, and the rotational encoder measures the number of rotations, and there's a timer. So by the number of rotations, the timers can determine distance and time, determine the velocity. The problem is that when you throw the bar on the ground, you have to be very careful not to throw it on the device. That eventually it happened. Murphy's Law. It happened that one of these devices was smashed, and so we had to purchase a new one. Together with these devices, we also used another very interesting device that is laser positional device. Essentially is a device that is attached to the end of the barbell and has a sensor, emits the light that is reflected by a surface and then receives the light back. So by measuring how much time it takes from the light to get out of the sensor and coming back, you can determine essentially the distance of the barbell from the floor. It was a very neat device. I really liked it. The only cumbersome aspect of it is that you really need to have a reflecting surface, an appropriate reflecting surface. In fact, the device comes together with a little mat of a reflecting surface. Overall, I think that a phone app is probably one of those most practical things you can possibly do, because everyone has a phone nowadays, and it's quite simple to set up. It only requires to establish a distance of around 3 to 10 meters. So we are talking about between 10 and 30 feet distance from the lifter, possibly being on the side of the lifter, catching the entire movement in the sagittal plane, and it's quite practical.
All right, so let's bring the design of the study together. So could you list the devices and then what you compared it to get the accuracy?
Sure. So we had a total of 5 devices. We had what is called the GymAware RS, a Vitru, a gravity box, and then those three essentially are boxes with a cable. The principle of function is always the same. Then we had the Kinetic Flex, the device that is applied on the side of the barbell, and then we had the phone amp that was called the WL analysis, weightlifting analysis.
So 3 linear transducers, 1 laser-based measurement tool, and 1 phone app, so camera, 2 2D camera-based measurement.
Yeah, that is correct.
And your gold standard was?
Our gold standard was our motion capture system, an OptiTrack system that included 12 cameras.
Awesome.
Obviously, to make it work, track the movement of the barbell, we had to apply a marker to the barbell. We applied the marker to the side of the barbell. It's essentially, it's a reflective sphere. We performed the measurement, all the measurements simultaneously. So we had on one side, the 2 linear transducers and the reflective marker. On the other side, 1 linear transducer and the Kinectoflex.
Awesome.
And obviously the phone.
Yes, the phone on the side and 12 cameras around for the touch system.
Correct, yes.
Now, who were the participants? Who did you invite to the study?
Those were athletes competing at regional and national levels. Most of them were from a local gym, but they were we advertised the study in Florida, in our state, and actually we were very pleased by a couple of athletes that came from Tampa, which is located 5 hours driving from Miami, and they explicitly came to Miami and they drove for 5 hours just to be part of the study, and this was really incredible.
In terms of comparing the devices, what measurements did you decide to use? And what movements did you test?
So for the measurements, we tracked the barbell velocity in clean and in snatch. We left to the participants to decide whether they wanted to power or to execute the full movement of the cases, and we wanted to measure the barbell velocity at different percentages of the maximum effort, just to see if there are any changes in the accuracy of the devices as the velocity increases or decreases. So we decided to make sure that every lift was a proper lift, and also for probably safety reasons, we wanted to limit the percentage of effort to 70%. So we had lifts executed at 40% and at 70%. Essentially at 40%, probably the barbell velocity at that point is probably quite high, I would say, but at 70% still you have a pretty high speed of the barbell.
The numbers, what the average or like median velocity of the barbell would be at 40%?
We are in the range of 2 meters per second. There are some values of barbell velocity that have been measured in the past, many years ago, and but those measurements were performed on elite athletes, and obviously I believe that the elite is always, biomechanically speaking, is a different animal rather compared to the normal population of excellent athletes, but still at regional and national levels. Like that, probably more similar to humans. In terms of clean, we are talking at 40%, we are talking about 2.3 meters per second. We take it at 70% is about 1.93 meters per second. And for the snatch, it's a little bit faster. It's about 2.5 for the 40% and around 2.2 around 70%.
Awesome. Was it mean velocity or peak velocity you were measuring?
No, we are talking about peak velocity. We were interested into measuring the peak velocity because it would just make more sense, in my opinion, within generally in powerlifting, the measurements that are reported refer to the peak velocity as well as the mean velocity within the entire lift. But we wanted to focus only on a variable that, in our view, made more sense for the sport. That is essentially the peak velocity, which expresses the maximum power you can express. We measured the 3 repetitions per lift at 40% and 3 repetitions per lift at 70%, and we averaged the measurements. And essentially what we did was to measure these velocities with all these devices, these peak velocities with all these devices, and compare them to the gold standard that was the motion capture system, and calculate the error. Essentially, we calculated the error as the difference between the measurement with the device versus the measurement with the motion capture system. And the errors that we found for all the values that all the lifts that we measured would vary between in the lowest case like 0.01 meter per second up to almost 0.2 meters per second.
Let's start from the most important thing. So which of the devices, if any, was the most accurate?
So we found two things. The first thing was that there was certainly a better device that was the GymAware. It was actually pretty accurate. The level of accuracy was the maximum error that we found was around 0.01 meter per second. And We also found that this error was unbiased. This means that there was no preference in this device to overestimate or underestimate the actual velocity of the device, of the barbell during testing, while most of the other devices that we found actually presented a bias, meaning that the Flex device, the phone app, and the True Box presented a negative bias, meaning that they tended to underestimate the actual peak velocity. And these underestimations were up to 0.18, 0.17 meter per second. Now, in order to get a sense of how important is this error, if we would extrapolate the value of the velocity of an athlete from 60% to 100% would represent the one repetition max. When we are in the region of the 95% to 100%, which is the region that most matters to us because it's the peak of the performance of this person, the change in the barbell velocity could be of 0.1 meter per second or probably less. So essentially, having an error of almost the double, 0.15, 0.17, represents a great limitation in this device for this particular application. Regarding, we actually was, obviously all these devices have a different cost associated to it, right? So the GymAware device was represented the most expensive type of device and something that is probably not immediately accessible to the general user because we are talking about around $2,000 or $3,000 to purchase it versus a phone app that is free or $9 without advertisements, right? So we were a little bit disheartened when we found that the phone app actually presented this big limitation. But I believe that the main limitation of the phone app is not on the algorithm that actually calculates the velocity of the barbell. The limitation is essentially in frame per second that the phone can acquire. So eventually, if you could have a phone that has, or a tablet or any device that has a larger frame per FPS compared to a regular iPhone or an Android, it is highly possible that you could significantly reduce the error in the estimate. The advantage of this, so one tool of this.
Well, could we just explain why frames per second matter? Why they are the limitation?
Sure, absolutely. Essentially, the software that is used in these applications essentially tracks the position of the plate frame by frame. So by tracking the position of it tracks the position of the plate and refers this position of the plate to an origin of a system of reference. So when the lift is about to start, the plate is in the lowest position. So the app generally boxes the plate into a square and determines the center of the square. The center of the square would be the origin of the motion of the barbell. As the frames go by, the position of that square that identifies the position of the plate changes in space. So a new center of the plate is identified, and obviously a new center has a different coordinate, different distance from the ground, right? That's what we want to measure. Now, the problem is if we don't have enough temporal resolution of the images, in other words, if we have only few images of the lift, we may miss the actual peak moment in which there is the maximum extension of the barbell before the velocity starts to reduce. So essentially, by increasing the number of frames per second that you can get, you would eventually reduce the possibility of making an underestimate or overestimate of the actual velocity.
So the camera is measuring here. The next photo is taken here. If the peak velocity happens here, that's missed. So we have this and this.
Exactly, you essentially miss it. So the larger is the number of pictures that you can take, allows you to take a better to appraising with a higher precision the moment in which you attain the peak velocity essentially.
So for the mean velocity, maybe it's not such a big problem because you kind of average all the measurements across the whole movement, like for example in squat. But for snatch and clean, where the movements are very fast, this loss of data is quite significant and will impact accuracy.
Yes, absolutely. I agree. And it's also a matter of, yes, Absolutely.
Okay, so GymAware, the most accurate, unfortunately the most expensive. Then phone app probably would be more accurate if the camera would be better. So maybe in few years we will get there where the general phone camera will be sampling in 120 or maybe more. I don't know.
I believe that if you could go for, I believe that you should go for higher than 120. Probably, yes, probably you should have. The good thing of the phone app is that you can also upload videos and analyze the videos. So, for instance, if you would acquire data with a GoPro camera that is pretty good at taking images with a very larger number of frame per second, you could upload this video into your phone or tablet or whatever device you want to use and analyze the data with this phone application. Obviously, this defeats the purpose of the practical aspect of having a phone in the gym and measuring on the spot. So it increases the difficulty of the logistic, if you want, the logistic complexity of implementing a barbell velocity training system.
But you could set it up at the competition. So it's, measuring maximal effort at the right environment, the optimal environment, which is a competition for a weightlifter without even touching the lifter.
Absolutely, yes. That's minimally invasive. I mean, it's non-invasive essentially. Yes, non-invasive.
So I just wanted to move to flex device and these two. So could you comment on these? How did they perform in terms of accuracy and what were the problems?
So the B-Tube also had a performance that was comparable to the phone app. And it's also true that B-Tube was the lowest cost position device of the three that we tested. Flex also had an error that was in the neighborhood of 0.1 meter per second, a little bit more than 0.1, 0.12 meter per second, according to the type of lift. Probably Gravity Box was the next best device after the GymAware. Still included an error of 0.1 meter per second in the clean and the max and 0.05 meters per second for a snatch. So in my opinion, would be still problematic when you are interested into determining the actual peak velocity at very high percentages.
Do you think if obviously most of the coaches will not have access to motion capture. So this level of data accuracy is unattainable for a casual coach or the coach who is not working in a sports center or Olympics preparation center. So would it be still worth buying a linear transducers, or they are basically at the level, apart from GymAware that is pretty accurate, are they at the level of the mobile app? How do they, from the practical sense, how do they line up?
Well, I mean, from the practical sense, I think that besides GymAware that it showed to be extremely accurate compared to the others, these other linear transducers, they are not designed, well, they could be certainly used for this purpose with all their limitations in accuracy. But I think that the main limitation is the risk that you can actually break them because of the nature of the type of lift that you do. So I wouldn't feel comfortable in a gym if I were a gym owner, I wouldn't be comfortable in purchasing such a device with the high risk that it is very possible that you can break it. Me personally, as a user, as an athlete, I wouldn't make this into this type of investment personally.
Okay, how about the flex device, the laser optical one?
Well, the Flex device actually still presented, in my opinion, still presented an error that is almost comparable to the phone app. We are comparing in terms of snatch, we are comparing an error that is 0.12 versus 0.1. We are pretty much there in terms of errors. So I wouldn't make that investment. It's a very cool tool. I think the principle is very interesting. It's a very nice tool, but according to the data that we report, it's probably not best. Certainly not best.
Do you think it is related, or maybe I will ask it differently. Why do you think it didn't perform that well?
I am not sure, honestly. I don't know if the problem is making sure that there is the right illumination, the surface presents wrinkles, the reflective surface, the mat that you place underneath presents wrinkles, or there are differences in the index of reflection within the mat, or there must be some dust deposition that changes this index of reflection and probably can change some. I don't know. honestly, why it didn't perform it didn't perform as expected. Let's
At the end, I always ask a question about the favorite lift I asked you before. So if people are interested, they have to go to the previous interview. And I have a different question for you. You are very well versed on both sides, the research in weightlifting and the practical side. You are an athlete and you tried velocity for programming and so on. So you are a coach too. Now, if you could change one thing in Olympic weightlifting as a sport, what would it be?
Wow. I think that the sport as it is conceived is very simple, right? Because it's probably, I would say, a better way of determining an objective way to determine whether the lift is valid or not. When we talk about pressing and position angle of the elbows in pressing, in snatch, and in the jerk base. If we could have a system implemented that can objectively determine whether or not the lift is valid, well, there is actually a system they could actually replay, but maybe in real time, I don't know.
Yeah, just to make this experience a little bit transparent, more transparent for the audience, I guess.
Yes.
All right, fair point. Now, where people can find you if they want to follow your work or contact you about your research?
Oh, well, they can look up our website, and we also have a Twitter account. And every time that we publish a new research or there is a new thing going on in our lab, we always tweet, and they can always consult for any type of information regarding us on the website of the University of Miami, Florida.
Okay, could you mention the handle for the Twitter account?
Yes, that would be UM_biomech.
Awesome.
We did it.
Thank you, Francesco. It was a pleasure.
It was my pleasure.